The next is the configuration pages. So the configuration page starts from page 16, and there are altogether 4 pages which is used for configuration. In page number 16, only 2 bytes are important, that is the byte 0 which says MOD, and the byte 3 which says the auth 0. These bytes, byte 1 and byte 2, that says RFUI, they're all unused bytes, and I think the if you ever have to write to page 16, we have to keep these 2 bytes as zeros. The next, in byte 17, we have got the access byte, and we have got something called VCIT, and the remaining 2 bytes are not used. And the 18th page, we have got the password. So the password takes the entire 32 bytes. And in byte 19, we have got the pack, which is again related to the password, and the remaining 2 bytes are not used. So the other two numbers here, that is the 37, 38, 39, 40, they all the corresponding page numbers in the next version of um, this ultralight. So probably here, I think here, what you can see here is, is MFOUL21. Probably this is the one for the card with the higher memory. So down here in table 6 is explained the bits in the MOD configuration byte. So there are only 2 bytes, we need to 2 bits, we need to set here. One is the bit 2, which is said strong modulation enable, and that's all. In the access byte, we can set the PROT, that's the protection and configuration lock, and the auth limb, which again one of the important properties. So keep in mind the auth limb takes 3 bits, so you can have a value from 0 to 7, and whereas the remaining configuration bits takes only 1 bit. So we have the explanation about what these fields are. Now this is a 1-bit value. I can either set this to 0 or a 1. So I still can't figure out the usage of this. I just keep it to the default value, which is 1. So the default value is 0 here, if you can see. And auth 0, it is in bit 8, and it says auth 0, it's not, sorry, bit 8. So if you go up in documentation, the auth 0, sorry, takes the entire byte. So it takes 8 bits of values. So the number 8 means, the size of this auth 0 is 8 bits. So what the documentation says is auth 0 defines the page address from which the password verification is required. So depending on what exactly we want to do in the application, I can set the values from anywhere from 0 to 255. And if it is set to 255, or a number which is higher than the last page address, it effectively means the authentication is disabled. The prod bit indicates whether it is a write access protected or both read and write access protected, which is mentioned here. The CLK, the configuration lock. So you can use this bit to protect the read and write access to configuration itself, which is most often done. So when we configure our card for a specific application, we can lock this configuration pages altogether. So the documentation says 0 means it is open to write access, and 1 means both it's locked permanently for write access. The next is auth limb. It's the documentation says limitation of negative password verification attempt. So this takes 3 bits, so you can have a combination from 0 to 7. So this basically tells how many times we allow for a wrong password verification, after which the card gets permanently locked. So I'm going to explain this all when we see the actual card. The next thing is VCT ID. It says the virtual card type verification. So this takes 8 bits. So this is something we can write. Probably we can use this to indicate what type of card it is. So probably I can write the value 25, and any card that have the value of 25 in VCIT, I can treat them as belonging to one particular type of application or usage. It could be an event management, or I can have a value like a 26, which could mean it's like a travel card or um, a royalty card type of applications. The next thing is the password. So this takes 32 bits, so you can put any value here. And the pack value, this is called as a password verification or acknowledge. So this is 16-bit value. So these password and pack, you cannot read them. Whenever we read, we'll always get the value as zeros. So there's something important in this remarks section. As you can see here, the configuration log bit activates the permanent write protection of the first two configuration pages. So it's something, there's some important information here. This bit logs only the config 0 and config 1 pages, not the password or a path pages. So the next thing is we have got the password verification protection again. So it mentions about how the password is stored, what the size of the password, and what is the initial values of auth 0 and pack and so on. So the next section is again about password and pack. So what we have to keep in mind here is what it all means is the section 8.6 8.61 is we can write a 32-byte value as a password, and we can set from what page number we want the verification to to start, and we can also write the value of the pack. So when after successful password verification, the value of the pack is returned. The next thing is all about how the auth lim field works. So it says the initial value is zeros here. So when the value is 0 means we are not limiting any negative password verification. So we will let any number of wrong passwords, which is not used most often. So you can go up to a value of 7 maximum. So after that, so all your password protected access rights will be completely disabled. For example, if we protect the memory for read and write, and after this auth lim exceeds, you cannot read and write at all. So the next thing is about the counter functionalities. As I mentioned before, there are 3 counters in this type of tags, and each counter is of size 24-bit, and these are the one direction counter. You can keep on incrementing, and it also says the initial value of the counter is 0, and they are pretty simple when you read. It also speaks about various commands, which I'm going to explain in the later videos. So there's something called the originality functions. So probably we can use this to verify whether the entire cards are actually manufactured by the NXP. So there is a command called read signature, which we can use now to get a 32 byte cryptographic signature, and you can verify that whether this signature is a valid one by using this ECC public key. Probably this is available from NXP website. So next thing is about the virtual card architecture support. Again, I'm not very clear how and when this is used, but one thing what I know is when we configure or when we set up our application using ntags, I can write a value for the VCTID, and there is a command, and using that command, I think that command is called VCSL command. So when you send this command to the card, you'll get back this VCIT. Probably if this number is passed on to our application will come to know what type of card it is talking to. So after this, you got these are the various types of commands that are available that are supported by this tag. Most of these commands are very similar to the Ultralight. Some of the new things are, say, you got read count, the increment count, the password authentication and read the signature, and the check tearing event, and the VCSL command. All above commands are like one more thing. Sorry, there's something called the get version, which is used to check the originality of the card.